Now let us understand what is a characteristic equation of a linear recurrence relation which is homogeneous. Okay, as you can see, if this is my recurrence relation, then for such a case where my recurrence relation is homogeneous, the characteristic equation is given like this. It is an equation with degree k, and it is like this: C0 alpha raised to k plus C1 alpha raised to k minus 1 plus C2 alpha raised to k minus 2, so on up till ck equal to 0. Okay, over here this is a equation with a degree k. Okay, and the roots of this particular equation are known as characteristic roots. Okay, so I'm going to say roots of above equation are known as characteristic roots. Okay, so this is the characteristic equation. Okay, you are just taking up the coefficients. Okay, and over here you get the highest order term, highest degree, alpha raised to k, and over here you get the term with the lowest degree, which is the term with degree 0. Okay, and you solve this equation, you find out the alpha, then the roots, which is alpha 1, alpha 2, alpha 3, are called as the characteristic roots of this particular equation. Now let us understand how we are going to use the characteristic equation and the characteristic roots to find the solution of a homogeneous recurrence relation. Okay, by the way, what is a solution of a homogeneous recurrence relation? The solution of a homogeneous recurrence relation is the sequence, okay, or some function which determines the sequence. Okay, that function is also known as a numeric function. So the solution of the sequence is going to be your numeric function, okay, that determines your sequence. Okay, so let us see how we are going to reach to such a function. So the solution is given like this. For a homogeneous recurrence relation, the solution is given by AR is equal to A1 alpha 1 raised to R plus A2 alpha 2 raised to R plus A3 alpha 3 raised to R up till AK alpha k raised to R, where what are these alpha 1, alpha 2, alpha 3, alpha k? Your alpha 1, alpha 2, alpha 3 are the characteristic roots. Okay, these are the characteristic roots of your recurrence relation. We have just seen what the characteristic roots are. These are the roots by solving the characteristic equations. Okay, when we solve the characteristic equation, we get the characteristic roots. If your roots are distinct, then you have this as the solution. Okay, so this is for distinct roots. Okay, and if you have repeated roots, let us suppose your one particular root, let's say alpha 1, is repeated m times. Okay, then what you're going to do is you're going to replace alpha 1, you're going to replace this particular term with, I'm just going to write it, then replace